Hello, dear viewer. Today we will explore the Mandelbrot bulbs. The Mandelbrot bulbs are the circle-like structures which are touching the main cardioid of the Mandelbrot. Let us begin this journey by starting at the biggest bulb, the bulb to the left of the main cardioid. This red dot marks our current location. We will call this dot our travel point. Let's see what path we would take when we iterate through the Mandelbrot formula at this travel point. We see that we are just jumping back and forth between two locations. Let's call this bulb a 2 bulb for that reason. In order to explore other bulbs, we will soon start moving our travel point. But before we start moving, I have to tell you that there are some very interesting patterns and relations with other entities to discover. In order to be able to catch these relations, we will split the screen into 4 quadrants. Each of the 4 quadrants will give us a different perspective on what is happening. I will not yet explain what these 4 quadrants show. Instead, I will start moving the travel point, and I encourage you to just observe what is happening on the screen. If you want, you can try to make sense of what these quadrants show, and maybe you even catch some patterns and connections between these quadrants. Afterwards, I will explain what is going on in each quadrant, and I will reveal some connections between them. But for now, I will be quiet and let you observe. Could you make sense of what you were seeing? Did you catch any patterns? I will explain what is going on. In order to do that, Let's go back to a more suitable position for our travel point. Let's first examine the quadrant in the bottom left. Our travel point is currently covered by some of its path points, so for clarity, I will encircle where it is at the moment. The travel point seems to be inside a bulb, and if we have a look at its path points, we can see that they are jumping between 4 locations. That's different from the bulb we started our journey. At that bulb, the path points jumped between 2 locations, hence we called it 2 bulb. So then, let us call this bulb 4 bulb. Let us now explore the other quadrants, but let's keep in mind that our travel point is in the 4 bulb right now. Let's have a look at the quadrant in the top left. This quadrant shows a zoomed-in view of the travel point location. Let me mark the location of the travel point in this quadrant for you. That means that this bulb is the 4 bulb. But can you see anything in this quadrant that is related to the number 4? Let me outline something for you. This encircled structure is called an antenna. Every bulb has an antenna, but this bulb's antenna has 4 arms. There we have our connection to the number 4. Let's look at the next quadrant. Let's explore the top right quadrant. This quadrant shows the Julia set for the position of our travel point. This set seems to be connected right now, which is not that surprising since our travel point is currently inside the Mandelbrot set. But if we have a closer look, we again can find a certain 4ness in this quadrant. It seems that the Julia set here always branches out in 4 branches. Now let's look at the last quadrant. The last quadrant shows another red dot. This red dot is not our travel point, but it actually follows our travel point from the boundary of the main cardioid. It never leaves this boundary. Currently, it is at the exact touching point of the 4 bulb and the main cardioid. There is also a parametrization for the path the red dot takes. This parametrization uses an input value t. For the red dot's current location, this input value is 0.25. The 4ness in this quadrant lies in the input value. If you write 0.25 as a fraction, you get 1/4, 1 divided by 4. So the 4 is the denominator of the input value when written as a fraction. Let's get back to the view of the quadrants and have a look at all the connections in these 4 quadrants at once. These connections are not exclusive to this 4 bulb. In fact, every bulb has these connections. It is just that different bulbs have different numbers tied to them. Have you noticed in what order we traversed the bulbs in our journey at the beginning of the video? Let's go through that journey again, but this time a bit faster. We traverse them in ascending order without leaving out any natural numbers in between. But we leave out many smaller bulbs in between the bigger bulbs we visit in our journey. So what are the rules of our journey? The rule is that we visit exactly the bulbs that don't have any bigger bulbs anywhere past them along the boundary of the main cardioid. And since we happen to traverse every natural number, except 1, in ascending order that way, that must mean that the number of a bulb is directly tied to its size. The bigger the number, the smaller the bulb. Let's remind ourselves that this number is the denominator for the input value of the parametrization. And this input value gives us the touching point of the bulb with the main cardioid. For our bulbs, the numerator of the input value was always 1. But in fact, for every rational number as input value, we get a touching point with a bulb, and for every bulb there is a rational number for which we get its touching point. We call a bulb PQ bulb if the corresponding input value is P divided by Q. This video so far was focused on the denominator, so our 4 bulb was actually the 1,4 bulb. Now that everything what is going on in the quadrants is clear, let us take a different journey. This journey follows a different rule. Try to figure out what the rule is, and maybe you notice some interesting facts about this new journey. Could you figure out what the rule is? And did you notice anything interesting? If you did, please let me know in the comments. Either way, thank you for watching this video. I really hope you liked the video. If you did, please give it a like. It really helps the channel out. And if you want to see more videos like this, then consider subscribing.